Welcome back, everybody. This is episode 29 of my multi-cloud network architecture series. And in this episode, I've invited back one of my favorite partners from the Netherlands, Mark Noorman, who represents CloudNation. Mark, it's great to see you again.
Thanks, Dana. Happy to be here again. Good talking to you.
So give me a little brief on what we're here to talk about today.
Yeah, no problem. CloudNation has been growing quite rapidly for the past year. Of course, we got involved with a lot of new customers. And one of those customers hosts a call center platform on AWS. And we were called in to help them because they were having performance problems with one of their customers. And they couldn't get to the bottom of that to find out what the root cause was. So, helping them, troubleshooting them, it immediately struck me that how easy and how much more faster would it be if they would just have Aviatrix gateways and tooling available to troubleshoot these problems. It would have made life so much easier.
Yeah, that makes sense. And the application running in the cloud is a real-time app. It's a voice app, right?
Yeah. They like I said, they host a call center platform within AWS. So they have lots of different customers who make a call to some helpline of one of their customers, and the complete backend runs in AWS. So it can be 40, 50, or even more customers, and one or two of those customers are experiencing problems in a structural way. So there must be some kind of bottleneck within the network, and especially with real-time applications. What the white paper I wrote is about is if there's any structural problem in the network, you're gonna notice it immediately. There's no resiliency within the application that can remediate that or solve it for you. There's no no self-healing.
Sure. Yeah, it makes sense actually. I remember when I was doing on-prem networking, troubleshooting voice problems was even an issue on-prem. There weren't a lot of great tools. It was just hard to decipher exactly what was causing the latency or the jitter or the packet loss, when it was happening, where it was happening. There was no historical data, and it just drove us nuts trying to troubleshoot voice issues. It was intermittent sometimes. So I can imagine in the cloud, with even less cloud native tooling available at your disposal, it's difficult to get to the root cause. You're spending all sorts of time, wasting time trying to do post-mortem or troubleshoot. And I love that Aviatrix is able to bring Copilot to the table and make everybody's life easier. So let's dive a little bit deeper. I think you got a couple slides here that you can show us what you've been working on.
While troubleshooting this customer case together with my colleagues, it really struck me that such a call center solution definitely isn't the only workload running in a public cloud that has a similar challenge. There's lots of real-time applications, how they call them, that incorporate some kind of human interaction that are really susceptible to connectivity issues. And the public clouds are an excellent platform for hosting such solutions. Like, for example, Amazon Connect is a ready-to-use service combined with all sorts of native AWS services. The scalability, cloud gaming is available on Azure, and also those managed services combined with all the edge locations they have all over the world make the public clouds a great platform for hosting such workloads.
Yeah, exactly. You can build out these points of presence closest to the end users so that they have the best experience, the best end user experience. Especially for voice and video and gaming, you want to have the best latency, the lowest or no packet loss, and the lowest jitter, right? So this is fantastic. They have the power to spin up and spin down these points of presence anywhere in the world at any time in minutes. I can totally see why customers are going in this direction and building their next generation real-time apps in the cloud.
Yeah, I totally agree. And there's a lot of analytics tooling available for analyzing workflows and customer experience, all sorts of things. However, when you go back to the base, network connectivity, we all know the cloud providers don't provide you with that much insight.
And that's exactly why Aviatrix has been proliferating and exploding in recent times.
And when we look at those real-time application workloads, a lot of things can go wrong within a network. Like you already mentioned, latency is an important factor. You ideally don't want packets to travel more than 30, 40, 50 milliseconds. And then you also have variation in latency, which they call jitter. These are real-time applications, often using UDP. If you're using TCP, it is a self-healing factor, so we can ask a retransmit of a certain packet, so we can put the right frame together again. But UDP, it's just sent once, and the endpoint just has to make the best of it. So when in a real-time application, those packets are received in a different order than they were sent, you can imagine yourself a phone conversation becoming a bit blurry.
Yeah.
You go for video interaction, for example. Every end user will notice it immediately. If it's a gaming platform, the moment they hit that button, they want the screen to respond to shoot an enemy, for example. But if it doesn't happen or it becomes blurry, they really become dissatisfied. You want that optimal network performance.
Yeah, I remember those days when I used to play games, man. I would play Counter-Strike, and if I had a little bit of lag there, I was done, right? There was no point in playing. I would just get off the game. Awesome, Mark. I love to see all these Aviatrix gateways and the controller and Copilot on this new topology. So tell me a little bit what you've been proposing to this customer.
Well, everybody who's been following Aviatrix at least for a bit will know that the most important use case is multi-cloud. Like we see here, some AWS workloads and also some VNets in Azure with a transit layer above that. And in that transit layer, you can really collect all your edge connectivity to branch offices with SDWAN, for example, or remote employees, but also IPsec VPNs or ExpressRoute or Direct Connect. Everything will be able to come together within that transit layer. However, there's, especially for these real-time application workloads, Copilot, which is the monitoring, analytics, and visibility tooling of Aviatrix. This really has some great advantages for these workloads, because now you have the visibility of your network performance that is really crucial for your application, for your end users. Right. Now you get the insight of the topology, but also latency on individual links. Let's say one of these customers is complaining about performance, they will probably name it, my phone conversations are a bit blurry. I cannot hear what the other guy is saying, or the calls are being ended for no reason.
Yeah, so Copilot is going to be able to show you the per link latency, whether it's within region, across region, or across a multi-cloud, and soon down to on-prem over SD-WAN and whatnot. That's coming to the platform as well. But on top of that, we can show you the nitty-gritty details and flow data on a per call, per gaming session, for example, perspective. So we can even pinpoint what the throughput was of every single flow, what the latency was, what the duration was. We can get down to the SYN, the SYNAC, whatever it is. If it's UDP, we can see the UDP flow and how long it lived for. Like, all those details are being collected, and you can go back in time historically and find out what was going on and find the root cause of the problem. So I totally get it. This is perfect for this scenario.
Yeah, especially for real-time applications, it doesn't have to be multi-cloud, but this added visibility, these troubleshooting and analytics tooling to drill down in individual application flows, comparing to the baseline for the last couple of months. This provides invaluable insights and makes troubleshooting so much quicker and easier.
Yeah, love it. Baseline. That's exactly what it is. We can keep a baseline and see all the diffs between the baseline and figure out what the problem is really quickly. Love it.
And with the newly announced features on Copilot, which now also enables you to define all sorts of granular alerting. If a certain threshold is being crossed on CPU, bandwidth, latency, you name it. You just get notified. Hey, this gateway is experiencing this kind of issue by email, by Slack, whatever you want. I think it's a really great addition, especially for day two, as we call it, operations side of networking.
Absolutely, Mark. Mark, it looks like from this diagram, you're breaking things up into different segments. Tell me about what you're planning on doing with this.
Yeah, let's assume this the example I mentioned of our customer that has their workload completely deployed in AWS. Let's say customer one has a couple of VPCs dedicated for them running in AWS. And well, there's another customer two, that also has two VPCs. Like, for example, they don't need a test VPC, so they only have two VPCs with the workloads running in it. And well, there comes customer number three, and well, they host a web shop, for example, and they will use the call center functionality. But as Amazon is probably a competitor web shop, they demand that it's not being hosted on AWS, so they propose Azure. And then, well, especially with Aviatrix, the multi-cloud deployment becomes so much easier, and they just can expand the transit layer and deploy the necessary VNets with the workloads in it. And especially one of the great advantages, to my opinion, is the introduction of security domains, the ability to create and define logical domains and define which ones are completely separated from each other and which one can communicate with each other.
I love how you're showing real world application of the Aviatrix platform. We see this internally. I mean, we're working with 500 plus customers on a daily basis. We see requirements like this, enterprise class requirements like this all day long. And I'm so happy to see that you're also getting the same requirements from your customers. So there's two things here to talk about, two things to just point out. The multi-cloud network segmentation feature, which means you can have network segmentation across any cloud, any transit, any region within minutes. I'm talking VRF-like segmentation. Customers are completely separated from each other. It's up to you to build out those segments and those relationships using a connection policy. Minutes. It's so quick to build this out. You no longer have to figure out, how do I segment in one cloud or one region versus another cloud or another region. I don't have to play around with security groups or routing or firewalls. This happens in the data plane in seconds. It's brilliant what we've built out. And then this visibility is now available in Copilot as well. We just released multi-cloud network segmentation visibility in Copilot. And it's such a beautiful representation of how resources can talk to other resources across segments or within the same segment. The other piece of this is that you're able to stamp out the same network, the same architecture, again, in seconds across other clouds. So you build it once in AWS, you can do it in another region in AWS, but more importantly, you can build out the exact same infrastructure in Azure, GCP, Oracle, and soon Alibaba. We're bringing Alibaba here.
Oh, great. And of course, the same goes for the workloads. I know this customer deploys containers to host their workloads. It enhances the scalability. It's managed by Kubernetes, and that's such an all-round cloud agnostic technology that it's easy to deploy them on any other cloud platform as well.
Okay, I see some SD-WAN on here now, and I get a little bit excited about SD-WAN because my background was SD-WAN. I came from Viptela, and I've worked with all sorts of SD-WAN solutions out there, and large organizations are still using SD-WAN to connect on-prem to other on-prem locations, so spoke to spoke or spoke to data center, and in some instances data center to data center, but it's the physical footprint they're usually connecting. But now we're seeing everything move to the cloud. So the gravity is shifting to the cloud, and now they have to figure out, how do I connect all these existing legacy environments to the cloud in the most efficient way? And so it looks like you're using Aviatrix to do that as well, right?
Yeah, definitely. Of course, with Aviatrix, when you're using gateways within the transit layer, that integration becomes just so much easier.
Right, and some of the benefits of using Aviatrix at the edge to connect SD-WAN is that, first of all, you can carry your segments. All the segmentation you have in SD-WAN, you can carry them into those Aviatrix security domains that you showed on the previous slide. We can do a mapping, a one-to-one mapping, so that you have end-to-end segmentation and security. Secondly, you can force that traffic through our FireNet gateways. So service insertion is now available. We can select certain traffic and then pump it through a set of firewalls for inspection, for security correlation, whatever you want. Lastly, you have the Copilot visibility. When you terminate with Aviatrix, it doesn't matter what it is, partners, customers, direct connects, VPNs, SD-WAN, you still get the same amazing cloud visibility that only Aviatrix is able to provide in the market today.
Then I used to be a network engineer, working hands-on on switches, routers, etc. But also working with cloud for the last couple of years. Sometimes you just can't escape a packet capture. Mm-hmm. Sometimes it's just necessary to really dive into the packet, the TCP flows, UDP flows, and really troubleshoot what's going on under the hood. And looking at native services, for example, AWS, it has traffic mirroring. It's a great function. However, you have to set it up in order to be able to use it. You have to spin up an EC2 instance that has, for example, Wireshark to capture the traffic, and then you can start analyzing it. Mm-hmm. It's so cool that a controller has this function built in. Just select your gateway. You can do some granular filtering on IP address, source destination, etc., and it just appears in your screen. And if it's necessary, you can also export it to do some more deep dive analysis within Wireshark. But you don't have to set it up; it's available at your fingertips.
Exactly. Basically, you own the data plane when you build it out with Aviatrix. You own every node, every ingress and egress point, every spoke to hub, every spoke to spoke, hub to hub communication. You own it because you have gateways in line. And exactly what you're saying, you can jump onto the controller and run a packet cap on any interface, on any tunnel in seconds, and then export it to a PCAP, figure out your problem really quickly.
Yeah, then like I said, I wrote a white paper about this subject. I was inspired by our customer that was experiencing those problems, performance problems in the network, and I did some more research on it, expanded the topic a bit, and then made a translation of the most common challenges or problems that might arise with those real-time applications, and described how Aviatrix is able to solve a lot of those and offer some really great advantages on top of those native services.
I read the white paper and it was really impressive. Very thorough, very straight to the point. And I really recommend anybody watching this video to check out the description section of this video, and I'll have a link to the white paper. Download it, read it, realize the power of Aviatrix and cloud networking working together. Mark, always a pleasure to get with you and talk with you about all the things that you're working on over there in the Netherlands, and I can't wait to come visit you once all this COVID stuff is over.
Oh, let's do that. Yeah, it's great talking to you again. Always good exchanging experiences and ideas. I love this interaction.
Likewise. Thank you, everybody. We'll see you in the next one.